Okay, so coming back, we are seeing an unusual problem. Okay? And the way to debug this is to realize that we are getting these errors that look a little strange. Okay, so unable to read this memory block, some port error. Then we are not able to read even when we are here. You can see that we are not actually able to read any of these things. Okay, and so the telling part is here. So when we look at this GPIO initialization and configuration, of course we should have actually gone through the whole thing in detail. And one thing that I forgot to highlight is this section, initialization and configuration. So GPIO modules may be accessed through two different memory approaches. One, the legacy is the advanced peripheral bus, APB, and the other one is called the advanced high performance bus, AHB. Okay, same register map, but better performance overall. These are mostly exclusives, and whether we are accessing it through the AHB or APB is controlled by this. Again, by default, we are really not we are not changing this. Okay, note that GPIO can only be accessed through the AHB aperture. Okay, so this is slightly confusing in the sense that it says GPIO modules may be accessed via two different memory apertures, but here it says it's only through AHB. So that's seemingly contradictory, but we are not going to touch this anyway. And the addresses are known, so we don't really have to worry about whether it is AHB or APB also. The second one is to configure a GPIO pin on each port. We have to do the following. First thing is enable the clock signal to the port by setting the appropriate pins in this register. Okay, so let's go and see what this is. So this is on page 340, and let's just put a bookmark here so we can maybe come back here later. So let me see if I can put a bookmark here. Okay, so highlight this, and then let's jump to 340. So this is our general purpose IO, GPIO, run mode clock gating control software to enable and disable these. Okay, so now I want to enable port F clock gating. So what do I have to do? I have to set this particular bit, that is bit 5, I have to set it to 1. So what is this bit 5? This bit 5 is going to be out here. So 0000001. So I need to write to this particular register. Let's go back here. Let's stop debugging. And the first thing I need to do is to enable port F. I need to write this to hex 10. This is the 5th bit is being written to. Sorry, no, is it the 5th bit or is it? Sorry, it is the 6th bit. It is 0, 1, 2, 3, 4, 5. So it is actually the 6th bit, which means that this should be hex 20. Okay, so I need to write 20 to this particular register, but this is not the name as it is defined in our header file. So let's go and check what that is. So let's see if there is a clock gating. There should be a clock gating somewhere. Let's see, RCGC. There we go. So this is our RCGC. RCGC1, RCGC2. We should find one for the RCGC for GPIO, and that register happens to be RCGC2. There you go. So this is our RCGC2 register. Okay, and GPIO F is out here. Okay, so we found this bit, and this is port F clock gating control. Okay, and this is, of course, these are the big fields, but we don't care about the big fields. We want this particular one. Okay, so what are we going to do? We are going to go find this particular register in our defines, and there we go. So this is the register that we need to write. Okay, so this is the register that we need to write, clock gating control, and we need to write a value x20 to this. Okay, now of course, like I mentioned earlier, the correct way to do this is not to just write 20 to this, because this would necessarily write zeros everywhere else. Okay, so what we need to do is I need to OR this with x20. Okay, and again, this is slightly harder to read because we don't really know, what this bit does. Okay, so the correct way again to do this is to actually go and look at this particular one, right? So this is control for this, which has this value, and then we are going to OR it with this. So the effect of this is basically going to be to enable the clock signal to this port. Okay, so now let's do this again and see if things work. So clean, build project. So everything is done. Again, we get this one warning that our loop is not reachable, but that's fine because we know what we are doing, and then we start debugging. So now let's see if we can access those registers. So where are we? We are up here. Okay. So I'm going to close this, and I'm going to close this. We don't need these. This is our main. We are starting off. Assembly step debug. And now you can see that let's go and look for that GPIO register. So these are GPIO port F. Okay, unable to read, unable to read. There's no way we are able to read, and that's because our clock is not yet enabled. So let's go ahead and do single step debugging. So R0, we are loading in this value. So we read that value in. We are now doing OR, deploys OR, and now we are storing that value back. So now we have stored that value back. And now let's go and see if we are able to read these values. Okay, so still we are unable to read these values. So maybe we have made a mistake in trying something. But this time we are not getting errors because we are still able to write to these. So let's just see if, there we go. So we got a fault ISR, which means we have not done something correctly, and therefore we ran into this fault ISR, which means we are trying to write to something which is not writable. And obviously that is because we have not enabled our clock correctly. So back to the drawing board. Let's go and see what we have done incorrectly. Okay. So let's go and see what's going on. So sysctl, have we enabled the correct register or no? Probably not. Probably not. Let's go and double check. Probably not. So what we need to do is this control. What is this SCGC2? SCGC2. What is SCGC2? Okay. So what we have done is by mistake, we went and wrote to this register, sleep mode SCGC, sleep mode clock gating. So sleep mode clock gating control. Okay. What we have to write to was run mode clock gating control. Okay. So this is wrong and this is wrong, but of course we can sort of guess that instead of SCGC, we should look for RCGC. That should not be too difficult to find. So let's go and Why is it not able to find? Oh, we are looking for it in the wrong file. We should be looking for it in this file. So Control F, RCGC, and therefore this control RCGC2. This is the value that we should have used. So let's go and put this here. Okay. And similarly, this one also, I'm guessing instead of this, we should use RCGC. Of course, you'll see that the value will be same. Fine. There you go. The value is going to be the same because it's the same bit location. But for sake of completeness, I think we should use this one. So let's go and put this back here. So now it is run mode clock gating control. Run mode clock gating control. Now let's see if we are able to run this and debug. So save. Let's clean. Then build. And then debug. So we got successful build and then there we go. So now let's try. So registers, where is our GPIO port F? You can see they're all unable to read. Single step, single step, single step. Now we have been able to write. There you go. So now the value has been written and see. Now you are able to get all of these values from GPIO data registers. Right? Okay. So now let's do C single stepping. So GPIO digital enabled, pull up enabled, direction enabled. Okay. And the next step is going to actually enable the digital values on the port. So now I will draw your attention to this board out here and let's see if it actually does something. Okay. The single step here. We have written this value into this register over here, and now this next step should cause it to light up. There we go. So now the board lights up. We've got this light LED going. Right. So that's it for a very, very simple example. Now let's just check whether whatever we were trying to do in terms of lighting up all three colors, whether that works or not. So let's write a small loop here. We'll stop this. Okay, so what I want to do in this while loop is I want the LED to be off to begin with. Then I want it to be red, which means value of 2. Then I want the LED to be, basically I want this first bit here to be on, which means value should be 2. Then I want this bit to be on, which means value should be 4. Then I want this bit to be on, which means value should be what should be the value? Value should be 8. So let's try and put these three statements in here, and this should give us all the colors lighting up one by one. And then final statement, I'll put back XE, which is for all of these LEDs to be on. So let's try and build this. Clean. And then build project. So debug. Now this time I'm not going to do single stepping because I know that everything is as it should be. So I'm just going to go directly to, so all of this is done. So now you can see the first statement got executed, our LED is now on. The next step is 0. So setting it to 0, which means the LED should turn off. So LED is now off. Next one is for 2, so red LED should turn on. Then blue, and then green, and now white again. So that means these controls are working. So again, this is a very simple demo of how to debug when something is not working. How do you go and search in your data sheet and figure out what is going on and what did you miss. So always the data sheet is the data sheet or reference manual is the right place to go hunting. Okay. So we'll stop here and then I'll come back with the next module.